But my name is Rebecca. I'm happy to meet you all. It's wonderful to see you. I'm so glad to have you with us today. Today's topic is a really interesting one because I think it is a very important data science topic that is taught in almost no data science education programs. And I feel like I can say that because I've been teaching with a data science program for almost 10 years now. And I think that this is, while it's not a new topic, it's a very new topic for data science. And so I think that everybody who's here today in this webinar is sort of getting kind of early access to some of these ideas. And I'm really excited to hear your thoughts about them. I know Patrick is eager to get your feedback and your questions. Patrick is our speaker today. He was our very first employee at Rotational Labs. He's a distributed systems engineer. He loves rock climbing. He also is a big fan of October. He has a wild Halloween costume every year. You're just going to have to trust me on that. But he's very, very into Halloween and dressing up in costumes for Halloween. I think last year he dressed up as somebody from the Top Gun movie, which was amazing. But most importantly, Patrick is sort of what I envision when I think of what I want all data scientists to kind of be striving for, which is somebody who's really excited about the data engineering and the machine learning parts, and kind of willing to think about both of those pieces together and think about how all of those things fit together in a holistic way. And is not just kind of building machine learning models and throwing them over the wall to some other person. He's excited to roll up his sleeves and work on the full pipeline from end to end. And I think that that's what everybody in this webinar should be thinking about, right? That this is an end-to-end thing. And we want to understand kind of the whole process from beginning to finish. So I'm very excited to turn things over to Patrick. He's going to be teaching us about the PubSub design pattern and how to use it for data science. So take it away, Patrick.
Thanks, Rebecca. Hello, everybody. So hopefully you will enjoy the content of this webinar. This is kind of targeted towards people who might be new to PubSub, which based on the poll results, it seems like a lot of people are fairly new to it, so you're in the right place. I say that. So I want to start by talking about what we're going to talk about. So we're first going to talk about where our data might come from for data science, and then go over like what PubSub actually is and how, like at a high level, how it's supposed to work. And then we're going to look at what tools are available for data scientists, and then also actually dive into a code demo. It's going to be pretty cool. So first, I want to talk about something which I'm kind of dubbing the kaggle effect. So if you're not familiar with kaggle, it's one of the kind of it's a pretty popular data science community, I'll say, of people who are sharing data sets freely with each other, and also engaging in competition to learn more about machine learning and how you can parse and collect data, analyze it, and create machine learning models. So what I wanted to say here is that I think what this proves is that data scientists are really good at working with data sets that are bounded, right? So they don't really keep growing in size. Like if you have a data set like a spreadsheet or something, then data scientists are pretty good at extracting out all the useful everything useful that they can from that data set. but I think what we're seeing kind of more recently is that data scientists are maybe struggling a bit to deal with the fact that most data is actually more real time than you think. And creating models that keep up with that reality is kind of a challenging thing. And you know, as Rebecca mentioned, this stuff is not really taught in traditional data science courses, because so far they've kind of relied on the fact that you have like a bounded set of data and it's not coming in real time. So we did ask a question about in the poll about where your data comes from for data science. And it seems most of you get it from databases and spreadsheets, which definitely lines up with my experience. Certainly, like a lot of times at a company, what you're dealing with is that you have a database and then given to you by some other part of the organization, and then you're kind of asked to do all the data science stuff to it. So the thing is with that is that, you know, even though it is a database, it can also be changed over time, right? And potentially what you would be interested in is capturing those changes over time, as well as being able to train models on all the historical data in the database. And you know, these other data sources are also a bit real time, right? So if you have like IoT sensors or logs from your servers that you're getting from your observability tools, those things are also real-time data sources, right? So a lot of things in the real world are actually real-time rather than these static data sets that we're kind of used to working with. So basically what we need as data scientists is to be able to have access to these data sets that change over time and they're not static. So we need tools to be able to interact with these data sets as we would kind of like a traditional data set. So yeah, so what we're going to talk about today is the publish subscribe pattern, which is a method of interacting with real-time data, right? So what is going on here is that there are three parties usually in these types of tools, or at least two. You have publishers, which are categorizing these messages into topics, and subscribers, which are consuming on a set of topics. So what happens is that if you imagine, you know, back in the day when you're like ordering magazines, what you might do is that you subscribe to a magazine that's being published by a magazine publisher, and it's being delivered to you. Each issue individually is being delivered to you by mail. And the important part here is that you don't have to be engaging with the publisher directly, because we have the service in the middle, which is like the mail service, which is delivering your mail, and you don't have to be at your mailbox to receive the new issue or not, because you can pick it up at any time. That's kind of like the nature of asynchronous PubSub, right? Where the subscriber has a lot of control over what they actually want to subscribe, similar to how, you know, if you have a database, you don't get any data from the database until you actually like query it. So that is kind of the analogy that we're starting with. if we want to get into some terminology, more specific terminology, when we say event, we're talking about a single unit of data. And the important part of an event is that in a real-time system, you either receive or you don't receive the event. So it's like the atomic unit of data. And so one example might be like if you have a table in a database, like you think about a table of all the issues that have been published by Time magazine, and you have a single row in that table. That single row is, you could consider that to be an event, right? So this kind of maps the idea of like databases and tables to events and topics. So an event, it is a single, you can think about like a single row in that table. And then so you get that single issue. If you subscribed, you would just get a stream of those issues. And a topic is that stream of events. So it is like an ordered collection of those events. So if you think about all the issues that you receive from Time magazine over a year, then you would receive like a collection of those events. So that kind of looks like the Time magazine table in a database. So theoretically, as data scientists, what we should be able to do is actually query on these topics like we can query on a database. And so that's something that we would find useful. So now that I've kind of introduced some terminology at you, are there any questions that we have so far?
So people might be typing questions now. So, as people are typing any questions they have about anything that Patrick has introduced so far, or maybe just questions that you have kind of in the back of your mind about PubSub or anything like that, I'm curious also if anybody on this call has ever subscribed to a real magazine, like a physical magazine. And if you have, if you could put into the chat what that magazine subscription is, if you're willing to share. I will share that when I was a little girl, I used to subscribe to the magazine Highlights, which was kind of like a magazine full of puzzles for children, with little pictures where you would have to look at the difference between two similar pictures or do crossword puzzles and stuff like that, which, so that was what I subscribed to. I'm seeing some other things here: Sports Illustrated, National Geographic, Wired, Fine Woodworking, Reader's Digest, Wisconsin DNR, Lonely Planet, Tinkle, which I've never heard of. I love the name. Is that a piano thing? Rolling Stone, New Yorker, The Atlantic, Safari. So I'm glad that many people, I think, on this call have at least sort of an intuitive understanding of, what actual publishing and subscribing in the physical world looks like. So hopefully that helps with kind of building a mental model of how that works in the digital data world. So we do have a question, Patrick. Basically, publishers classify and distribute while consumers just get the data. Is that right?
Yeah, that's exactly correct. So as a subscriber or consumer, your kind of responsibility to yourself is you have to know which topics to subscribe to. Like you have to know which magazines that you're interested in, would be the analogy. And so it kind of distributes the responsibility between the publisher and subscriber.
And I think it's actually a really smart question, because there is one more piece that I think you haven't told us about
Yeah,
yet, that plays a pivotal role between the publisher and the consumer. So whoever asked this question, I think maybe already knows that there's a little bit more complexity going on. Like you can't really just do everything with just publishers and consumers. There's one more piece there in the middle that's very important. So I think we're going to learn about that soon. I'm going to check to see if we got any other questions. An event is basically like a record in a data set, and real-time data is inserted as an event. So is that the right way to think of it? Like that, should I be thinking about an event as a record or like a row in a data set, or maybe a document in a document database or something like that? And real-time data is basically just the act of like inserting another row or another document. Is that another way to think of it, or would you do you have any comments about that, Patrick?
Yeah, so I think that's a good question, and I think that is a good way to start thinking about it. You can also think about it kind of like in the opposite way that is phrased there, where you can imagine like if you have a database and you are having like a database is if you get like really technical into it, like it's basically just a log of all of the changes that have happened to the database. And something called call the change data capture log, which you can actually certain databases allow you to extract that and like look at all the changes that I made to the database. And that is actually like the real true nature of the database. So that is like all the events in the database. The other thing I wanted to mention is that like the records in I think the analogy holds if you assume that like the records in the database are ordered, because that's also a really important part of eventing, is that the events have like a defined order, and everybody has some agreement about what the ordering of events are. We'll kind of get to that, but yeah, thanks for looking at that.
So I just put in a quick link to the term change data capture that Patrick just mentioned, which hopefully also helps, if anybody is thinking about kind of from a database perspective. And I just wanted to call out, somebody asked if comic books count. I think the answer is absolutely. I also was a big fan of comic books as a kid and still am. And so I think with that, we can switch back to your content, Patrick, and we'll have another break for questions, a little bit later in the presentation. But if people want to keep adding questions, if you think of them, just go ahead and add them to the chat, and I'll keep track so that we get to them before the end of the webinar.
And I'll just say that my two magazines as a kid were Boy's Life, because I was a Boy Scout, and then also Time for Kids, I think. Those are two I remember reading consistently. So next one I would talk about is the actual tools for PubSub, and there are actually two classes that you can kind of think about when you think about PubSub. There are these synchronous like messaging systems, and there are also the eventing systems, which are really what we're going to be talking about in this webinar, because it has to do with eventing and has to do with like publishing and subscribing events, and specifically with asynchronous eventing systems, is that you have an event broker. And so this is kind of the magic piece that's sitting in between the publisher and subscriber. So similarly to how your mail service is the one that's responsible for delivering your mail from the publisher to your doorstep. You have the event broker in an eventing PubSub system, which is responsible for publishing all these events and getting them to the subscribers. And it actually does the main thing that this does is it separates the publisher and subscriber, right, and decouples them. So you don't have to be publishing at the same time you are subscribing, which is a pretty powerful thing because you don't have to coordinate between those two directly. And the event broker also has a lot more responsibilities depending on how complicated it is and how much how much responsibility it's actually taking from the publisher and subscriber. So it might actually enforce an ordering on all of the events that are coming into the system, so that every subscriber can tell and the same group can tell like what have the same ordering of events. It might also manage like offsets in for subscribers, so the subscribers can tell like what the last event was that they read without having to save that on their side. And another important part that I think is maybe often overlooked when people start looking at PubSub tools is that the broker might also save your data like an actual database you would expect a database to do. And that does not really happen by default for most tools because usually what they assume is that PubSub is more of a kind of ephemeral thing, and the data does not really stay around as long as it gets through the queue. The broker doesn't have to worry about persisting it, but some systems actually do have an ability to persist the data so that you can, as a subscriber, you can go back in time and see what the data was like in the past and do historical queries and stuff. So if we're talking about async PubSub, the kind of obvious benefit is you can have these publishers and subscribers which are operating independently, and it makes it easy to scale up your system because all you have to do is really just add more publishers and subscribers as long as the broker can handle it. And it also kind of leads into the idea of data pipelines because you can define how your data is moving through your system a lot more clearly because you have these topics. Like you might have a topic where you have the raw data, and then you have another topic where you've done some pre-processing on the data, and you have another one where you're training models and or kind of re-indexing data or something. So it kind of forces you to, or it allows you to create those data pipelines in a more obvious way. But some disadvantages might be that you really need to learn how to code things in a way that is compatible with microservices and these asynchronous patterns. And you obviously do need a broker in the middle to handle the messages that are in the queue still and they haven't been delivered to the subscribers. And so that is something that you would consider, like, do I need to, like, do I have the capability of like running that myself, or do I want to have some managed service to do that for me? So I don't have to worry about the DevOps requirements as much, and I can just focus on getting my microservices up and running. Another con might be that every time you're dealing with async, you have this problem where you can't ever like really ensure that everything, all your messages have been delivered until the subscriber says, okay, I got this event. Because that is kind of the nature of asynchronous, right? There's kind of this period of uncertainty where you've published an event, but you haven't actually received any acknowledgement from the other side. So that is also something a broker could help you with if it has stuff like handling X and X. So if you're trying to implement PubSub, like what tool should you use? So if you are kind of the type, the distributed systems engineer type who likes to get down and dirty with the details, and you don't mind DevOps, you could use Kafka, which is kind of like I don't know if I should say the original, but it's one of the kind of progenitors of this eventing messaging systems. If you're not really familiar with like going into those details and you just want to create quick applications, there's Azure Cloud or Azure Web PubSub. Yeah, so if you're a data engineer and you're just concerned about the data in your cloud that you already have in your cloud vendor for your company, you might just want to use like a native tool for that cloud. So I think like Amazon and Google both have tools, have a PubSub tools for that. Lastly, if you're like just a data scientist and you just want to use Python to create these data streaming applications really quickly, there are also some options for that. You could use Pulsar or maybe Ensign. And an advantage you would also go to that is that your data could actually persist. So you could train models on this historical data, just like you would train models on a regular, relational database. Okay, do we have more questions before we kind of transition to the demo portion?
We do have some questions. I think maybe a great place to start would be, could you say again, when you say eventing system, and maybe it would be useful to show the slide that showed like kind of synchronous versus asynchronous. I can't remember which slide that is. It might be, yeah. Potentially this might be a good slide to speak to, but like what is an eventing system and how is that different from the messaging systems? Kind of just like maybe restating the highlights there. I think that looks like something that a lot of people are interested in.
Yeah, that's a good question. So what I would kind of consider an eventing system is that you have the broker in between, which is actually managing and like ordering the events. So in like a traditional messaging system, you might just be publishing messages like synchronously. So you have two, like a publisher and the subscriber, which are hooked up to the same queue, like maybe they're even directly connected. Like when you publish messages, you immediately get a response back before you can publish the next event. Eventing is more like has to do with like event-driven architectures where you're specifically waiting for events to happen or messages to come in on the subscriber before you do anything. So most of the time, your subscriber will be waiting for things to happen, and then once you get an event, it handles that in whatever way you want that event to be handled. So it's kind of like two ways. It's kind of like a more of like a programming paradigm, like synchronous versus asynchronous is kind of the major difference there.
Yeah, and I think so. There's another question here that's I think related to this slide, which is does the event broker filter data that goes to the subscriber? So is there any kind of filtering happening? And I think that that's a good question. Just to kind of, is it, would it be if I just sort of thought about that broker section in this slide as just the database, where like the publishers are publishing things and they're sort of accumulating in this database, and then the subscribers can access stuff from that database. They could access it now, but also like if they wanted to re-access any of the old data in a month or 2 months or a year, they would maybe still be able to access that data. Can I sort of think about that center part as a database, which is what makes the eventing systems unique, that have a broker, makes those unique from kind of just like the synchronous messaging, where as soon as you send a message, it gets retrieved instantly and then it expires.
Yeah, I think you can think about it like a database. That's a good question, and I would say that like it is definitely like if you think about what a broker is at its most like fundamental level, like the broker should like not really be concerned with doing filtering because it is kind of just the party which is responsible for delivering messages between or events between publishers and subscribers. But if you want to think about it, but like you could have a broker that does some filtering for you to make it easier on the publishers and subscribers. Like maybe you don't want to see like duplicate events or something. Like if you publish things and if you publish 2 events and they're like the exact same event, maybe you want the broker to be configurable enough to filter those duplicates out. So it's definitely a something that is not impossible for the broker to do, I would say.
There was a question about exactly, I think, what you were just saying. So somebody wants to know, if let's say there are 2 events, essentially what would be like, let's say I write a new row to the database, so it's like a brand new event, and then a week later there's an update to that, right? So I'm like maybe updating something, changing something about the event. Like, how can you tell that, how do you determine if it's a new thing? Because in a database you would just upsert, right? You would change what is actually in the table. So how do we detect the difference between like a pure duplicate event, which is exactly the same event again, versus something where the metadata maybe has changed, or some elements of that have changed? How is that possible?
So I think I can think of like maybe 2 ways you can do that. Like one way is you utilize like an ID system. Like in a database, you have IDs for your different rows in the table, which is like the primary key, right? So you're able to use that to do the upsort in a normal database, and your subscribers might be able to use an ID kind of like a system like that, but it would kind of be more on the subscriber than necessarily like the broker maintaining like an updated state in the database. So generally, like, so the other option would be like you have to kind of rethink how your messages are working, like so or are designed for an asynchronous like eventing system. So the difference is that you're dealing with like the changes, and then so your subscribers would have to be able to kind of rebuild the state from all the events in the log, which is basically what databases do. If they, have to be like recovered from like a previous state or something. So you might have to have some logic in your subscriber, like depending on your use case, I guess, which is reading like the historical events and then kind of building the current state from that. And that's kind of like what you're expected to do in like an eventing system is you have the change data capture log, and you can rebuild this like a state at any point in time. So theoretically it's like more powerful than like a traditional database in that sense, but you do have to maybe do a bit more processing work to get to that point, unless you want to like be checkpointing maybe to like some external storage on the subscriber side, so you're caching like states maybe.
Okay, there's maybe one or two more questions, but I'm going to respond to them in the chat so that you can start your demo.
Yeah, when I get to the demo portion. Okay, so now we're kind of going to go into some more practical application of from PubSub. We're going to use Ensign, which is our kind of version of PubSub tool, and OpenSky, which is a free API for tracking air traffic. And so the use case we're looking at here is I want to use the API to track what flights are going over my house, because I live pretty close to municipal airport. So if you wanted to try to reproduce this demo layer, you would need to have an OpenSky account and an Ensign account. Both are free, and you need a Python 3.10. So those are the two dependencies are PyEnsign, Python package, and Python OpenSky. So this is a pure Python example. And first thing that you would usually do in like a use case like this is you define all your data flows, which you need to have for your project. So in this project, we are going to have two topics to start out with, like those are two data flows. And what happens is that what we want to have happen is that we want to have one program which is publishing to this flight positions topic, and another program which is going to subscribe to that topic and then publish to a text updates topic. So that's going to give us like some humanized text for the flight. And that's kind of like a good starting point for our project. So the subscribe and publish pattern here on the right side is kind of a very common pattern in this type of in PubSub, right? Because you usually want to subscribe from a topic and publish to another topic, because that is a more resembles like a data pipeline. So that's kind of the general thing we want to accomplish with this project. And I guess I think we should go. I just kind of want to get to the demo before I break for more questions, but so PyEnsign, you can just pip install as a regular Python library, and when you're doing PubSub with Ensign, this is the easiest way to go about that. So you can use decorators, which are, if you've used stuff like pipe tests in the past, you might be familiar with a decorator pattern in Python. But basically, what you can do is mark your functions as publishers or subscribers, and then what happens is that when those functions return, when your publishers return a value, it'll be published to Ensign automatically as an event. And when your subscribers are receive updates, it gives you an iterator which you can iterate over to get those updates. So here we're dealing with this flight positions topics. On the publisher side, we are we are first fetching the flights from the OpenSky API, and then each flight we're going to yield that back to this publisher. So using the yield is, if you haven't used that before, it is kind of like your friend in data streaming in Python, because it allows you to limit the amount of data that you actually have in local memory, because you're only processing things one at a time, rather than like loading everything into memory at once and then processing it. But so every time we call this get flights, we'll basically be publishing a bunch of events to that flight positions topic. And on the subscriber side, it's more of an event-driven thing. So and that async for will be waiting for each for that generator to return every event, and then on every event we'll do something with the event. So that's kind of like the publisher subscriber decorator API by Ensign that we're going to look at implementing. So now we can actually get into some code here. So I'm using I have a Jupyter notebook, and I'm importing publisher and authenticate from Ensign. So one thing we haven't talked about is authentication. The way we handle that in Ensign is that you can pass it from your environment, or your credentials from your environment, or you can pass it from like a JSON file or directly. So we need credentials for our project. So we have to go to our dashboard here in my Ensign, make sure I'm logged in, my Ensign dashboard. I have a lot of projects here, but I'm using the flight tracker project right now. So I have created a new project some time ago, and I created two topics here, like one for my flight positions and one for the text updates. And I also created a new key. So the key is what allows me to actually interact with this project. Without it, I would not be able to do any PubSub. So basically what I've done here is I've already downloaded my key ahead of time. So in here, I have my key, I have my credentials defined here for Ensign. You also need credentials for OpenSky, so I have those here in this JSON file. And so this configuration is just about loading credentials, and then I'm defining a bounding box. So this is like defining what the latitude and longitude coordinates are for the box I want to capture flight updates over. So this is so I didn't want to publish too many events to run out my API key, my credentials for OpenSky. So this is just over the state of Minnesota approximately. And the publisher is so it's first authenticating with OpenSky every time you call this get flights function, and then it's getting the JSON response from OpenSky over this bounding box, and then what we're doing here is we're just creating a dictionary here and getting all this data that we got from the API back into some format, which we can define our event data in. So this is just a dictionary or map, I guess, yeah, in Python. And that's all you really need to publish data, is that you define the publisher in the topic over this function. So every time this function is getting called here, we will publish a bunch of events to Ensign. So that's on the publisher. On the subscriber side, we also need to authenticate with Ensign. And here we're doing some work on the subscriber side just to keep track of all the call signs, which are corresponding to the flights. Because I want to tell if this is like a new flight or this is an in progress flight. And ideally you would this info, you wouldn't need to have like any sort of local storage, and you can just use like the storage within the topic to do that. But for right now, we're just using some local storage to make this demo a bit faster. And by local storage, I just mean in memory. So if it's a new flight, we're just going to return this text that's detected a new flight. If it's in progress, we're just going to return this in progress text. So at least we can see like, is this a new one, or is this flight something we already saw? So here I have defined a subscriber, so that the subscriber will get updates from this topic, from this flight positions topic, and then for each update events, I will iterate over it and then print out a specific update. And this is like the tricky part here, is that this print update is also a publisher. Like I've defined this as a publisher right here. So what this allows me to do is that every time this returns the text value, it gets published to the text updates topic. So now we can start the subscriber. And now it's just waiting on this topic to get updates. So you don't see anything yet because we haven't actually published anything into the topic. If we go into this flight positions topic back in the dashboard, we can see that we have a bunch of events I published already, like earlier this week. So we'll keep this number in mind, 11,821, and then see if that number increases. And then similarly for this text updates one, I have 3695. So then what I'll do is that I will start the publisher. So we'll actually be publishing some real-time flights now, flight updates. And then hopefully we'll see that there are actually flights going over Minnesota right now. So we got a bunch of these JSON updates into the flights topic. And then over here, theoretically, what I should see is that I have a bunch of updates going into the text updates topic now, because I published them to flight positions, and then I subscribed to flight positions to get the updates, and then I published to this text updates topic. So here I have a bunch of new flights from most of them from the United States, some are from different countries, and then I start to get like the already in progress flights because my publisher has been running for a bit now, and now it's publishing some new updates for updates for existing flights. So if I go back to the dashboard and I like refresh this page, I should see this number change a bit, right? So we have a bunch of new updates now, and I can even query on like what the last few events were. So I guess we'll go 12,380. And then I can see like what the last few events were here, and I can actually see the JSON payload. Similarly, I can go to the text updates topic, and we'll see that this number of events has changed. And then I can also submit a query here. So you notice this is kind of very reminiscent of normal SQL. So now I have some of the most recent updates for these flights, which I just captured. So these are the text updates, which are being published by our by this code here in this notebook. So if we were to go, we can even go back in time here by submitting another query, like we'll just start at the beginning. We can see like what are the first ones that were ever published. So this kind of proves that we're able to retrieve data from way back at the beginning of the stream, like when I started this like a few days ago, when I started publishing to this topic. Yep, so that's like the main demo here. Actually, were there any questions while we still have a few minutes on the demo?
Let's see, I am checking. I've answered a couple questions asynchronously in the chat. I do see a new question in the Q&A. So someone says, in the GitHub README file, it gives instructions for how to run the Python code from the command line. Is it possible, however, to copy and paste the subscriber publisher code into a Jupyter notebook and run it from there?
So that's a great question, and you absolutely can. So as far as I know, that code also works in Jupyter Notebook. I'm presenting a different version or different version of the API, which is a bit easier to use, but you can also use the normal client style API if you want to in a Jupyter Notebook, and it should work.
And if it doesn't, you can email Patrick directly.
Yeah, if it doesn't, I'll
we'll make sure that the Patrick's contact info is in the email that goes out with all of the materials after the webinar, so that you can reach out and ask a friendly question. And Patrick has spent a lot of time with this code, and I think that he'll be excited to answer any questions even after the webinar is over. Okay, another great question. And this is, I think that this question to me signals that people are actually starting to really absorb what asynchronous means. So that makes me feel very excited, because I think that asynchronous design patterns is something that most data scientists really do not get training in. So this question is, will the code still run even if you close your computer, or will it stop?
Yes, does the refer to the like what as it depends like what we're talking about, like are we talking about the publisher and subscriber code?
Yeah, yes, the publisher and subscriber scripts.
Yeah, so the scripts, if you stop, like if I were to stop my computer now, I would stop publishing flights, and I guess I would also stop subscribing flights because I'm also running the subscriber on this computer. So, and it's actually a good question about because it kind of raises the point that, you know, at the point where you shut down, like how many, like how much have you published? Because there could be stuff that you're publishing when you shut down the computer that was in the queue on the client side and did not make it over to the server. But everything in that has made it to the server should be still in the topic. That makes sense. So basically, if you shut down my computer right now, it would stop publishing events. And because I'm sourcing events from this computer, I'm not like triggering the Ensign server to do it for me. I'm just using the Ensign server as my broker essentially to publish.
All right, I think that we have made it through all of the questions. We have 1 more minute. I wasn't sure if there was any quick thing you wanted to show on the screen, Patrick. But I think that we can kind of wrap up here and just let people know that we would love to look at your code. If you want to try something out, you'll get a link to this, the Ensign examples repo, which has a bunch of code snippets and examples in Python that you can experiment with. And if you make a fork and open a PR with your own example, we will send you a t-shirt and a sticker. And if you do it as part of Hacktoberfest with DigitalOcean, which is happening during the month of October, then I think that probably DigitalOcean will also send you a t-shirt, because I think they are giving out t-shirts for people who do open source contributions on GitHub during the month of October. So you stand to get 2 t-shirts. One from Rotational and one from DigitalOcean, if you manage to open a PR in the next 30 days or so. So we would love to hear from you. And if you get stuck on anything, don't feel bad. This is new. There really aren't a lot of blog posts about how to do this, because PubSub is very new for data science. So if you're feeling stuck, it's not your fault. Just reach out to us. We're all really nice. We're happy to answer your questions. We're so excited that you decided to spend an hour with us, and I hope you have a terrific rest of your week. Thank you so much, Patrick, for putting this together. That was a really cool demo.
Thanks. And also unfortunately, I think the t-shirt for Hacktoberfest might be virtual this year.
It's a virtual.
Because there's so many people who want to contribute to yeah.
Well, the
Hacktoberfest is really popular now, so
the rotational t-shirt is real though.
Yeah, that's real.
I actually have them in my house, so I can vouch that they are definitely real. So hopefully we'll see if you didn't get your question answered, please send your questions to support@rotational.io and put in the message that it's a webinar question, and I will be happy to respond to those. Thank you so much, everybody, for attending, and have a great week.